Hey everyone, this is Mayur. Welcome to MLWorks. In this video, we'll talk about Sentence Transformers Library. It is a simple framework used for computing the dense vector representation or generating embeddings for your text or image data. And it provides you with what many transform-based pre-trained models like BERT, Roberta, and Distilbert, and other many models with respect to images. And in this part of video, we'll talk about installation aspect and a few specific features of this library. Okay, and with respect to installation, you can do a pip installation using pip install sentence transformers, or you can do a conda installation if you have a conda environment. And if you don't have both, then you can do what clone this repository and start working on it. Okay, and with respect to CUDA, so this library, whenever you do some inference or training, it will look for GPU in your system. If it has that, it will use it. Otherwise, it will switch to CPU. Okay, and as part of different tasks that it can handle. Okay, so there are a bunch of tasks you can handle with this particular library. First is generating the embeddings. Then you can do semantic textual similarity, paraphrase mining. There are so bunch of tasks which you can solve using this library. And also these are already pre-trained models you have. So what you can do is, if you have your own data set, then what you can do is you can go and do a training on your data set using a pre-trained model. So that is comes under training overview. Okay, so if you go to training overview, you can pull in your data and take an existing pre-trained model and add additional layers that can learn your data sets features, and which will be better representation. The model will be better representation of your data and will perform better for your data set. Okay, so you can do that. And also the bunch of pre-trained models which are supported by this library is available here. So you can look at different data sets on which it has been trained on, and how it performs, right? But also we can look at it: performance of semantic search, what is the speed, what is the model size. So all these details are available here. So you just have to go here, training overview, you have it here, and the list of pre-trained models is available here. Okay, so this is just a basic overview, and we'll just run few bunch of lines based on this library. First, we'll start off with pip installation. So we do pip install sentence transformers, and here we can look at different set of dependencies that is required to run sentence transformers. So these are a bunch of libraries which are its dependencies: torch vision, hugging face, transformers. Okay, other CUDA based dependencies for GPU, and other basic other dependencies are there. Okay, so these are getting automatically installed once you do sentence transformer installation, right? So this may take some time because based on this size of these libraries, okay, the whole installation may take some time. And once the sentence transformers are installed, you can import that package, and then you can load some pre-trained model here. And you can see I'm using all mini LM L6v2. And the description, if you go to pre-trained models, you can see the details of those particular pre-trained models here. Okay, all mini LM L6v2, and the details of those particular model. So if you go back to the notebook, you can see those details. Okay, trained on large and diverse data set of 1 billion training pairs, and the input sequence is of about 256 it can take in, and the output dimension generated is 384, and the size of the library, and this evaluation metric, right? Evaluation score functions. Okay, so these basic details is already present here. Okay, now what we'll do is we'll take in a list of sentences and try to generate embeddings on it. I'm taking two list, sentence 1 and sentence 2, and then I'm trying to generate an embedding using model.encode, and I'm converting that to tensor, that is PyTorch tensor. Once we have this embeddings generated, we can see the shape of those embeddings. We are getting 3,384. So we have, since embedding 2 is a embeddings of sentences 2. Okay, we have totally 3 sentences. So 3,384. So per sentence we generated a vector of size 384. Once an embedding is generated, then what we can do is we can compute the cosine similarity between these sentences. Okay, and here we computed the cosine similarity, and we are printing it out here. So we can look at based on these sentences how the cosine similarity varies. So if you see the first two sentences, it has some action done. Okay, and plays in the garden, sits outside playing guitar or watches TV. Okay, so these are some actions. It can be done by anyone. Okay, so for example, here it is cat, and it is dog, and it is man, and it is woman here. Okay, so why I'm talking about this in detail is because here also we have similar sentence. Okay, and we can see how this transformers, not the transformer, the vectors, which the vector score we got here, the computing score, cosine score, changes when we change a word from dog to cat. Okay, so if you look at this score for this first sentence, it is 0.28, and I'm running this particular cell, eighth cell. Okay, and I'm generating these pairs, and let's sort it out and let's see. So if you see here, the cat sits outside. Okay, and it performs some action, and cat plays in the garden. Okay, so this is also an action. The only thing we have changed here from the previous sentence which we saw earlier, that is dog plays in the garden, cat sits outside, and the cat sits outside and the cat plays in the garden. The only word we changed is cat, and the score is changed from 0.28 to 0.67, which basically means that the value addition of cat, okay, the word cat is much more dominant in this particular sentence. That's why we can see the cosine score getting changed so much. Okay, and the other thing I want to share here is this is just one list we have, and we are generating embeddings for that particular sentences, and we are trying to score within these sentences. We are trying to score our cosine similarity. So what will happen is this particular sentence will be compared against every other sentence. Okay, similarly this particular sentence will be compared against every other sentence. So that's what happens when you do like this cosine similarity of embeddings, embeddings. Okay, this is just some basic Python code we are doing here, finding the pair with the highest cosine similarity and sorting those pairs. Okay, so one thing to notice is we are doing, so every word is compared with every other word. Okay, which is time consuming. So what sentence transformer library provides is something called as paraphrase mining. So here we just have 107 sentences. If you have 10,000 or 1 lakh sentences, and if you want to do a comparison, like how we have done here, like in a for loop, okay, so this will take a lot of time and a lot of resources to compute. So what sentence transformer provides is a paraphrase mining, okay, and which will do it for you in a much more efficient manner. So this may require you to go and read the documentation here. If we go to paraphrase mining, so what I've understood is if we pass 20,000 list here somewhere, right, instead of computing all pairwise cosine score and ranking all possible combination, the approach is a bit more complex and insufficient. So they are performing something called as chunking in terms of your corpus, and try to evaluate on a lesser number of sentences or corpus, okay, than doing it for the whole corpus. They are just chunking a part of it and try to generate these cosine scores. Okay, the time complexity is reduced here. If you see here, this two lines, okay, here it is given. This is done to reduce the memory requirement and increasing both values, and improves the speed but increases also the memory requirement. Okay, instead of getting and sorting all 2 power n pairwise scores, we take each query only the top 100 scores, and with so top 100 scores we find the at most 100 paraphrase per sentence per chunk. Okay, so basically what the whole point is, if you have just few sentences, then you can go ahead and use this cosine similarity which we have done earlier, And if you have 10,000 more than sentences, if you have, then you can better go for paraphrase mining, and it will give what efficient scoring mechanism. So as part of this video, I will discontinue from here, and will look at some other features in the next video. Thank you.